All right, hello. Today we're going to do 2.10 lesson. All right, sorry, I was writing it and got it wrong. Let's revisit our exponential function quickly. So let's say y is equal to 3 to the x power. This is exponential function because x is in the exponent, right, with a base of 3. About a few weeks ago, we learned how to convert to the, how to find the inverse function, right? So how do you do that? You switch x and y. So I got x is equal to 3 to the y power. Are you good? That looks weird, so we're going to convert this exponential form into logarithm form. How would that go? Log, let's see, the base goes in the little subscript over here. Exponent goes on the other side, and that argument goes over here. Remember that? So base goes here, argument is the answer, exponent goes as the answer of the logarithm. So if I were to rewrite this, the y of inverse is equal to log base 3 of x. So that and those two are inverse of one another. Are you guys good? Okay, so if they are inverses, then we will expect the characteristic of the input-output values of an exponential function to become characteristic of output-input value of the logarithm function. That was one of the things we learned, like how all of the input of the exponential become output of the log. Output of the exponent becomes the input of the log. They just switch everything. So, excuse me. Let's look at this table. Sorry, it keeps flicking. I don't know why. It's my old camera. Alright, so for exponential function, like this, y is equal to 3 to the x power, over equal with input value interval, that means your x is increasing the same amount, like 1, 2, 3, 4, 5, or 0, 2, 4, 6, 8, or 1, 4, 7, 10, 13. The output value is y changes multiplicatively. I can't even say that. So what do I mean by that? Look at this table, everybody. Look at how your input x value is increasing. I noticed my input is increasing by 2. So you're adding 2. Look at your output, the y value. What happened? 2, 4, 8, 16. Do you realize that you have to multiply by 2 on your output throughout the whole thing? So this is the exponential function. So it's okay to notice how the input x are changing additively, equal spaced by 2. While the output values, the y value, are changing multiplicatively, multiply by 2 each time. This is the indicator of the exponential function. Particularly, this is actually y is equal to 2 to the x power, x minus 1, I think. All right, so when I take that 5, plug it in, 5 minus 1 is 4. No, it doesn't work. Then what would that be? X. We don't have to do it, but I don't have time for that. Anyway, that's an exponential function. Now, what will happen with the logarithm? So see what happened. I took this input value and I put that as our output of the log. I took the output of the exponential and I put that as our input of the log. So your x becomes y, your y becomes x. Switch over. Then what can I say? Now your input of the logarithm is multiplied by 2, while your output of the logarithm is added by 2. So this is how we explain. Notice how the input x are changing multiplicatively, while the output are changing additively. This is the logarithm function because they're the inverse of one another. Okay? If this is hard to remember it, what I do sometimes, I just make a random exponential function, like y is equal to, because exponential is my best friend, right? I just make it up, a random, and I just plug some values in, okay? So like 1, 2, 3, okay, so 2, 4, 3, no, 8, wow. And then I see, okay, so that's added by 1, that's multiplied by 2. Okay, so if I can think of what's happening to input and output, I just make a random exponential function, okay? So inputs are additively, and then outputs are multiplicatively, like over here. And that makes me think, oh, okay, that means the logarithm is going to be the opposite. Input is going to be the multiplicatively, whereas the output is the additively, what you can see over here. Okay? All right, so let's look at the table. and determine what happened. So that's what you really are doing it. What happened to your inputs? What happened to your output? So look at your input. 1, 2, 3, 4. Duh, you're adding by 1. So that's additively. What happens to your output? 16, 8, 4, 2. Ah, I am dividing by 2. And you know dividing by 2 is same as multiply by half. So that's same as multiplicability. So what is this? When inputs are additively, outputs are multiplicatively, that's the exponential function. So it's inputs increasing by 1 while outputs are halves. Yeah? All right, look at B. 10, 30, 90, 270. Ooh, looks like your input is multiplicability. What happened to your output? They are additive. You get the point. So it kind of got flipped, right? So that's going to be the logarithm. That's all we're doing. 5, 50, 500. Okay, so I multiply by 10, multiply by... Okay, so input is multiplicably. 1, 2, 4, 8. Ooh. Output is multiplicably as well. Wait, have you seen this? No, neither. Right, okay. Looks like you multiply by 2. Looks you subtract 3, which is same as adding negative 3. So inputs are multiplicably while outputs are additively. Yeah? Alright. Next page. So, focus. Alright, I'm going to make another video.